Hey, how are we doing, everybody? Let's make sure we are on the short delay right now. We're good to go. What is going on? I'm getting everything loaded up right here. There we go. You have a 320 question? Let's do it. What do you have for 320? What are you wondering about for 320? Let me get my 320 over here on the screen. Got all the visualizations. What's up, Andrew? Good to see you here. Thank you so much for those timestamps, Andrew. They were a huge help. I was able to go through, easily put them in there. And so I'm getting 320 loaded up. Do we get a good enough class server response for a third? I'm gonna send that out today, and hopefully we're getting that response. I'm gonna announce that in class tomorrow. I'm gonna send that out today, and I need to talk to Dr. Emery about that. I need to say, hey, let's go for a third drop right here. Whoo, got everything ready this week. I'm getting everything ready over here. So we should, I think we'll get it. We should get it. We deserve it. Doing great working on the final review. Finished assignment 10, 320, but watching to make sure I did it right. Yes. 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 And I think that's what questions are there on 3. Jennifer has some questions on 320. Let's see right here. What is Jennifer wondering about 320? Let's go to the main screen. Let's do this. No, you were a huge help, Andrew. That was huge. It was really nice. I saw all the things that inspired me. And I went and did all the off stars. I still got to do videos from last week. I haven't put all the timestamps in them. No, I think we're all just like, we're in that, if you ever run a race, you're in that last little bit to the finish line. You're like, just got to make it. Just gotta keep running. We're almost here. We're almost Thanksgiving. We got this. And then we're just going to get to Christmas break. We're just going to like fall asleep just for all Christmas break. Let's see right here. What? If you're doing logistic models, now here's the biggest thing. Is your Y categorical, or let's do quantitative first. Quantitative or categorical? And let's go out here. And let's go quant is LM, or cat is going to be GLM, and family equals binomial. So those are key things right there that we need to know. This is a mistake that I often see people make, is that when they have a quantitative Y, you're using LM. When you have a categorical Y, you're using GLM. I've already seen this mistake, and I haven't, since if people are working on the take home, I don't tell them what the issue is, but I'm kind of like, check your code, which, it's like, okay, something's wrong. Oh, is it totally? No, I know it. It's so common. Check to see what your Y variable is. So make sure your Y variable, if it's quantitative, use LM, and if it's categorical, use GLM with family equals binomial. It's such a common mistake, but remember, this changes what model we're doing from logistic to regular regression to linear regression. So there's a big shift right there. It's either just quantitative linear regression or logistic regression. Oh my gosh, million files of them right there. What other questions are there? Keep asking questions. Did you? Oh, that's what you said. I keep getting an error message when I'm trying to fit my model. That seems to be it. This is probably it right here. Andrew, anyone else? 32474 201. 201's got has whatchamacallit. We have chi-squared. This is one of the most common issues I see. Chapter 19. Let's cover some chapter 19 homework. Chapter 19 homework. Let's do it. Good to see you here, Rocky Top. Let's do our launching this. Drinking some nice and healthy water. I'd prefer some coffee. One of these days, coffee. One of these days, I'll get to drink coffee again. Let's go to chapter 19 homework. Okay, chapter 19 homework. Let's take a look right here. It's the one about gender and party affiliation. I ran into the LM-GLM problem too, but figured it out after yelling at your computer usually does fix it. Yelling at your computer can solve problems, surprisingly. I mean, it somehow works. Sometimes you yell at your computer and the problem gets solved, and you're like, well, I guess that did it right there. So this is the gender and party affiliation one. I would not suggest doing this problem by hand. We should know that we're doing the chi-squared test of independence. We don't do the homogeneity test. We do the chi-squared test of independence. Now, whenever you look at these, I ask that you not read their answers because they're trying to trick you. Oh, cool. That's just the thing for, you can't even see it. It's the thing for the Kahoot. Kahoot later today. Be there for the Kahoot after class. So whenever you see this, you want to think what do I have open for these? I'm sorry. 2 seconds here. Let's close out that. Close out this. Let's open up a new Word document. New Word document. Here we go. Love the new work documents. There we go. New Word document. Okay. So whenever you do the chi-squared test of independence, I ask that you do the following. Now they'll try to trick you at different words, but you want to look at the two variables, and you have her here. Hey, what's up, Dan? Good to see you here. You have here party, and you have here gender. So whenever you do the chi-squared test of independence, you just want to say independent. Hopefully I spelled that correctly. But you just want to say that party is independent of gender is the null. That's the easiest thing to do. The null is just whatever your variables are, just party is independent of gender, or gender is independent of party, whichever way you want to say it. Usually it's X is independent of Y. And then we look to see if any of them match that. Look right there. Political party is independent of gender, but then we have to be careful because they're giving us choices that are different. Well, so this is the only wrong one we know so far. But then this gives a more likely scenario. But this is exactly how I'd phrase it. Either we have that X is independent of Y or X is not independent. Now, here's a hint. Sometimes they say that they're associated. That means the same thing as not independent, means that they have a relationship. So I like to say that they're independent as the null and they're not independent as the alternative, but you can put that they're associated. Do you know some way where we could practice problems for the exam? These are really great practice problems. And the Canvas content quiz. The Canvas content quiz is really great too. Basically, all of your Canvas content quizzes, which I think you can review, are basically example problems that could be on the exam. We take them from the question bank. So being able to practice here and seeing like different formats is really good. And My Pearson's pretty good. And the Canvas content quizzes are really good too. Also, check out the review videos. Check out those review videos that we got up. Those are huge. Condition 1 is random, but it's asking about count data. Count data just means that this is categorical and this is categorical. By having a contingency table, we have count data, so this has to be met. You literally have to have count data to have this table because it's categorical. Is randomization met? I wish they would say it. Does it say? In our problems for the test, we will say it's random. Next, we have expected cell count. Now, this is where we're going to pause and talk about expected cell count for a moment. I'm going here and copying the data. Please take note. This is how you copy the data right here. You go in and you copy to clipboard. You go to a new JMP data table by going to File, New Data Table inside of JMP. And with your new data table, make sure to go to Edit, Paste with Column Names. If you do not paste with column names, it'll look this way right here, and this is the wrong way of doing it. Oh, yeah. No, practice as many as you can. You practice different problems on the homework since Saturday? Yes. That is the way to get it down, is to just know all different versions of what we could ask you. And I really think Canvas content is a huge help because, and I should look at that, the correlation between Canvas content. We can go to tables, stack. I wish I could do it right now. I just want to see like, how well does Canvas content predict how someone will do? And I can tell people next semester, be like, do the Canvas content, even though, I mean, why would you not do it? I went to tables and stack. Now we're going to go, and we're just going to put gender right here because it doesn't make sense that that doesn't have a label. Just double click it and write gender. Then we're going to go to analyze fit Y by X. This is key right here. You have to put gender in the X and label in the Y. And then we're going to put data in the frequency. A lot of people forget to put data in the frequency right there. With all this here, we just click OK, and we get our table, and we're going to do something really nice right here. We're going to remove all of these, and we can actually look at all of the expecteds. So there's all of the expecteds, there's all the counts, and here's all the cell chi-squareds. And this is this whole chapter. Everything we have right here is basically the whole chapter in this one test. You should know how to find any of these. Who in the chat right now can tell me what is the mathematics to get 19.77? What is the mathematics to get 19.77? You should know how to get the mathematics for this pretty quickly. Who knows in the chat the mathematics to get 19.77? Who knows in the chat the mathematics to get 19.77? Who knows in the chat? How would we get 19.77? Yep, this is chapter 19. This is chapter 19. Oh, no, this is chapter, it's chi-squared, yep, which is chapter 19. That's correct. What is the mathematics for this number right here? Your table didn't return right? Did you put in the frequency? Does it look like when you get it, does it look like this right here? Does it look like the one on the left? Is that how it looks? Does it look like this one right here when you do it? Yes, definitely. Is the practice exam not have the key? Ting Yang, send me a reminder on that, and I'll give you some bonus for it too. Send me a reminder. Oh, just the jump spreadsheet? Send me an email. When you say the spreadsheet doesn't look right, are you saying... Got a lot of tabs open. So when you copy, make sure to go and do edit, paste with column names. So start a new sheet. So go to a brand new sheet and then go to edit, paste with column names. Did it look like this when you copied? Oops, I did it again. I did it twice. There we go. Does it look like the one on the left when you copy right there? Is that what you're seeing is like the one on the left when you copy? Okay, so are you on this step right here? Does it look like this right here on the right? Is this how it looks right here? Okay, good. Now go to table and go to stack. Go to table and go to stack. So with table stack, double click D, double click R, double click I, and then click OK. Tables stack, and then double click D. Sorry to inject the review quiz for 320 final is cumulative. I thought someone was just covering the material. Did he make it? Oh, I'll have to look at, sorry about the Timothy. It should not be cumulative. It should not be cumulative. So let me see what Dr. Lou posted. He mentioned that he made that. And let me see the questions he posted. It should not be cumulative. It should not be cumulative. I might need to revise this. He said he posted a 20 question quiz. Let me go take a look right now. And I said, that's excellent, but I didn't know. Let me go look at this in the meantime right here. I need to see this immediately. No. Cumulative, not good. We said no cumulative. Where is it? Review for final. Okay, I think I found it. Taking a quick look at this right here. Questions. Oh, yeah, he did. He has simple linear. I'll come to a decision about this. I'll talk. I mean, he already made it, and then you get unlimited attempts at it. And then there is things I'm going to cover tomorrow, and there's unlimited attempts on this, but we will not have cumulative on the final. Yeah. There's only two things I haven't said. Do you have to type this out? I might take a look at this. Yeah, the final will not have cumulative stuff on it. So I'd go ahead and finish it. He just set it up this morning. I'm very thankful for all the time he put into it, but I'm just like, oh no, I didn't know it was cumulative. He didn't mention that he made it cumulative. So I'm like, oh no. Oh no. No cumulative. I don't want cumulative. So right here, we put the following, the red ones in the X and the Y, and then the data into the frequency, and then we get the following right here. I might have had it set up differently, but let's go take a look at our table that we have. What do we have right here? Okay. So what is the mathematics we need to do to get the 19.77? What is the mathematics we need to do to get the 19.77? 201, what do we do? What mathematics do we do to get that 19.77 right there? How would we multiply the numbers and get that? Who knows? I've got my favorite song to play while we think about it. Just love listening to this. See if someone can get it before the song ends. The suspense. No one knows. How do we get that 19.77 right here? Let's show some hints on the screen. So what I've done right here is I've written the formula row total times column total over grand total. And so you'll notice these kind of point in on it. This is the formula for the expected right here. The expected cell count. Well, this is not quite degrees of freedom. This will be an expected cell count. And so we literally, when you look at this 19.77 right here, it's literally the row total. So the row total is 89. The column total is 44. The grand total is 198. And that makes, if you just solve the mathematics, like if you solve this, you will get the total of 19.77. We did stuff like this in BAS 320. We did row total times column total over grand total, and this is chi-squared, the discrepancies and all that. So what do we do? This is a good question here. How do we get this cell chi-squared right here? What is the formula for, let's go with, I'm trying to find the nicest one. This one right here. This one right here, you'll notice, is basically 1. And so how do we get that? It's going to be the observed minus the expected squared. Observed minus expected quantity squared over expected. And you get all these formulas on the test. And this is equal to a cell chi-squared. This is a cell chi-squared. So let's put a cell right down here. This is a cell chi-squared. So what is the observed in that cell? Well, the observed and the expected are right here. The observed is the top one, and the expected is the lower one. So that's the expected right there. And so let's go ahead and solve all this. And the observed is 29. And then minus 24.22. And then we have to divide by the expected. If you see, it's almost 5 squared over 25, so that's why we're getting sort of a value like this. But if you solve this all out right here, you will obtain the value of 0.9424. So that is how we find a cell chi-squared. Then how do we find the test chi-squared? If you take all of these numbers down here along the bottom, and we're going through all the theory on this question, basically. You take all the numbers down here on the bottom. What do we do with all these numbers? This is on the Canvas content quiz, and it's in the Kahoot today. There's a teaser question for the Kahoot today. Kahoot, I think it's at 4:45. It's right after class. So what do we do to all the cell chi-squareds to get the test chi-squared? The chi-squared test statistic is found how right here? How do we find the chi-squared test statistic with all those numbers? So we found an expected count. We found that one. We found a cell chi-squared, and then how do we get the chi-squared test statistic? Who knows how we get the chi-squared test statistic with all these numbers? What do we do with the cell chi-squareds to get the chi-squared test statistic? We've almost covered the whole chapter. To get the chi-squared test statistic, let's play some Mega Man. It's Punch-Out. What am I saying? What's wrong with me? I don't know Mega Man from Punch-Out. What do we do with those cell chi-squareds? We take all the cell chi-squareds and we add them up. So if you notice right here with all these cell chi-squareds, we're going to take every single cell chi-squared. And that's what you get in this jump output. We have right here's our jump output I think we're using. So the jump output right here shows the cell chi-squareds are all added up down here at the very bottom. And Dan, you were mentioning degrees of freedom. This is the way we practice degrees of freedom. So if anyone's watching this video in the future, doing the assignment, you look at this right here and you say, Brian, this is a what by what? So we look at this and we say, Brian, this is a 2 by 3. So how do you know you add up all the cells? So and I'll show that here in a second. So how many degrees of freedom does this have? So degrees of freedom, remember, so this is a 2 by 3. So then you drop one finger on each hand. So this is a 2 by 3. What are the degrees of freedom? So 2 by 3 turns into what by what? You can actually view the degrees of freedom visually if you put an L in right here, because you're deleting one row and one column. and you can actually see the degrees of freedom. Nice job, Dan, right there. There's the degrees of freedom. So there's 2 degrees of freedom. It can technically be any of them, but this is just one way to make sure you see the degrees of freedom. Do not use the total columns. Do not use the total column for the degrees of freedom. It said, yeah, this one's a 2 by 3. So 2 by 3 turns into 1 times 2. Now, what we were mentioning earlier about all the cell chi-squareds, when you have all the cell chi-squareds, you get all these and then you add them up. So literally, if you were to add these all up, if you were to take every one of these and go, I'm going to do a short kind of version of it. If you go 1.7983, why not do the whole thing? Plus 1.1542, as long as I don't type a wrong number. 0.3496 plus 1.4683 plus 0.9424 plus 0.2854. Oh, I might have missed a number. Oh, no. There it is. Look at that right there. We did it perfectly. So you need to remember this right here. The Pearson has your p-value, and wow, did these results turn out interesting. Why did these results turn out interesting right here? Why did these results turn out interesting? That's so crazy. That'd be a fun test question. Why did those results turn out so interesting? What we're going to do is we're going to draw it on a chi-squared. Yeah, it's about a chi-squared with 2 degrees of freedom. It's a chi-squared with 2 degrees of freedom, and we landed at 6 basically. So chi-squared is equal to that. 5.998, and then this right here, which I might have drawn a little too big, but close enough, that is going to equal to the p-value of 0.04. Yep. And it's almost exactly 0.05. It's barely statistically significant. And so we understand where all these numbers are coming from. The degrees of freedom tell us which chi-squared we are using. Let's go show that real quick right here. I'll pull up a degrees of freedom thing. So stat distributions, chi-squared. If we go here to 2 degrees of freedom, it changes the shape. 1 is really slanted, and 2, it gets the bump around 3 or 4. I was thinking chi-squared 3 or 4. So, and look, there we go. And it's so close that it's, I might actually have to use R for this because it's basically rounding it up. And that's one of the bummers on these. So you have to go here to, so it's Q norm, right? Q norm, I can put in this. That's all right. And then let's go with Q chi. What is chi-squared on this? Let me try. I'm going to find out real quick. Q norm. There's the norms. I don't know how to do it. Chi-square distribution in R. I've never done the chi-square on this. Let me check this out real quick, then I'll finish the question. Does no one have the code? Oh, it's Q chi-square. And they have to put in degrees of freedom. And so we don't want to do that. We want to do P of it. Okay. So P chi-squared and 2 degrees of freedom and 5.9982, I think it was, and then 1 minus. There we go. And that is the p-value we're getting. That is the area to the right of that part of the chi-squared. And so we did a really long version of this. It's really nice to kind of use some of the software to help out. Let me put that link to the, of course, it's stat distributions. And here you can even copy this one. There you go. There's that. And I like the stat distribution site. I love the visuals it makes. It's so close to, it just rounds up, and it's such a bummer. There it's finally below it, but it's really nice how it does the visuals instead of us having to do it this way. And this will give more decimal place accuracy. Awesome. Have some fun in Terry's class. See you later, Dan. Have a great day. What else do we have right here? Let's go finish the problem. We meet the expected cell counts. All the expected cell counts were greater than or equal to 5. That's the wrong one. Did we close it out? Nope. So all of our expected cell counts are greater than or equal to 5. That's all we need to check. Larger than 5, larger than 5, larger than 5, larger, larger, larger. We're good there. And so we're good on this. That's good there. What is the chi-squared test? We found it via jump just a moment ago. I think that's it. Yes, that's it. What's the p-value? There's the p-value. We're good on that. and reject or fail to reject the null. So, yep, we will definitely have office hours. I'll probably put out some schedules for it, but we'll definitely probably not on Thanksgiving. I'm going to spend that with my fiance. We got the turkey last night. Got some turkey breast. So, gonna make turkey, gonna have leftovers, and yeah. So, no Thanksgiving office hours. We're gonna have a Kahoot on Sunday and all that good stuff. No, we're definitely gonna have lots of video help. And I'm working on a new thing. Fail to reject on mine because yeah, exactly. So we're going to if I reject, does that mean there's evidence or there's not evidence? If I reject, does that mean there's evidence or not evidence? So if I reject the null, should I say there's not evidence for the alternative, or do I say there is evidence for the alternative when I reject the null? Yep, whenever we reject the null, there is evidence for the alternative. So we reject the null because the alternative there's evidence for. Great job right there, Timothy. Insane points right there. Can you go over some of one? Yeah, of course, definitely. You're here, you get to ask the questions. We just finished one. And always feel free to put a question up while I'm working on one, and that way I'll jump into it. But no, you asked at a perfect time. We don't have any questions right now. So let's go over to assignment. And number 1, you say. Let's take a look. Let's do it right here. And here it is. Okay. So in this one right here, we are going to work with the donor data set. And let me pull up. I've got so many things open. It's in absolute insanity, everyone. I'm illegitimate. Maybe I can get it tomorrow. Let's take a look right here. Oh, you're not a legend yet? I'm here to make dreams come true, Timothy. That's what I do. I make dreams come true. Let's make it for tomorrow. You can come in and flex and be like, yes, I am a Stat Nation legend. I just like having fun with this at the end. It's been a lot of fun, like giving people legend status. But you've been here for a long time, Timothy. You've definitely earned it. So you are now a Stat 1 legend. I know, right? Exactly. Is there an Exam 3 study guide on Stat? There should be. I'll show that real quick right here. There should definitely be an Exam 3 study guide on our webpage. Don't let me down now, webpage. So let's go to exams, exam 3, review material. I need to remove those Kahoot pages because I haven't updated them lately. Yep, looks like everything's up and posted. And I might update this too because this has like the list of videos. Does it have the ones at the end? It does. So this is a really good, got tons of review on here. Like there's just tons and tons and tons and tons and tons, like practice problems, stuff right here. So definitely going to the webpage, checking it out, going through the videos is a great way to practice. And so I'm probably going to suggest that today. Like, look, there's tons of videos up right now. Like you can go to any one of these topics and I would just try to review as many as I can. And a lot of them are very short. Like if you go over the type 1, type 2 error, this video right here, how long is it? 4 minutes.
And this is not good for the
owner. It's definitely not a I gotta look at all the pictures and everything.
Also will be
So I try to make it nice and easy, and I go through and explain the questions. So check it out, random YouTube advice videos right there. You think if I watched all it's concept review. Have your notes out while you're doing it. Make flashcards while you're doing it. Like if you watch a 5-minute video, try to watch it over like 20 minutes. So if I'm studying, I might try to watch like 3 videos an hour and have note cards out while doing it. And I would take notes because you don't just watch a video one time and know it. I mean, imagine if all of us could just like watch a video and know something. That'd be so cool. But even I have to practice things a lot. Like whenever I'm coding, I mean, I get tons of practice because I teach. So I'm really lucky. Teaching is really cool because you get to like learn things even better and you get to like make mistakes. Like I had forgotten how to do the chi-square and I was like, I have to look it up again. And so when you look something up, you have to like relearn it. You have to be like, okay. And I already know how these functions work a little bit. I just couldn't remember the name of the function. It's practice, practice, practice. A logical predictor for someone's last amount is the average amount he or she donated in the last few years, recent average amount. However, the strength of this relationship may depend on various factors, such as if somebody is a homeowner. So we are going to include the visualization of last amount, recent average amount, and their homeowner in their interaction. But we need to know what about last amount. So what do we need to know about last amount first? Last amount is the y variable. So what should we know about our y variable? 320, what should I know about my y variable when making this model? What should I know about my y variable when making this model? What should I know about my y variable when making this model? I'm going to do both while people are thinking it over. What should I know? Oh, I didn't do data equals. Which EX? There it is, EX5. What should I know about my y variable? I guess. You're right. Charlie, right? Nice job, Charlie. Charlie, that's worth. Let me give Charlie some points here in a second. So we mentioned a hint earlier. So what we need to know about our y variable is this. We need to know if our y variable is quantitative or if our y variable is categorical. So we need to know if it's a quantitative, like how much do we spend at McDonald's? Just want to eat McDonald's. Or if it's categorical, like I think I messed up my picture yesterday. Or is it categorical, like is somebody going to make a purchase or not? So categorical would be like, will someone make a purchase? Quantitative is going to be, oh, Charlie, gosh, Charlie, I'm going to catapult. Charlie, you've been here forever. I love it. And you're answering 320 questions. Charlie, what status are you at, Charlie? Because you're earning a new status. Charlie, you are now up there. Let's add Charlie some points right here. You are at the next level, Charlie. So we give Charlie some points right there. And so it is quantitative, which means we're going to use this model right here. And this format right here, Charlie, is just classic y tilde x, comma, data equals. So Charlie, I'm going to put this in the chat right here. And I want you to tell me, if I have a data set, here's just a practice problem for you. If I'm going to use a data set called Survey 10, this is the name of the data, and I want to make a model that predicts height from weight, what would we make for our model to predict height from weight? Like height is the y variable and weight is the other variable. And if you use this format right here, what would your model look like to make this with code? What would your model look like to make this? I'll remove this one because it is quantitative. So what would your model look like with y tilde x, comma, data equals? Charlie, you got that. I know. Thank you, Timothy. Cheering on Charlie. I love it. Stat Nation. We're here to help each other. Like, Charlie's actually going to write some code right here for the first time. And let's see what Charlie writes down. I'm excited. Charlie, show us some code here. We've got one model written up here. This model has an interaction. That's what the star means. This means we're doing the interaction between two x variables. No, I just want you to fill in this code with, we want to predict someone's height from their weight using the data in Survey 10. So kind of look at the format of this right here and then think about how you would predict someone's height from their weight using Survey 10 data. And so what code would you write to predict somebody's height from their weight? There's a 1 for, you might just send me a screenshot, but Jump says there's a 1.0 for P. Did you get, Rocky Top, did you get the following graphic? Does your graphic look like this? Tell me if your graphic, because I think this will have I think your graphic might look like this. I think your graphic might, and if it does, then go to this, go to relaunch right here, and under relaunch, make sure data is in frequency. Make sure data is in, Charlie, coming to the rescue. That code will work. I'm gonna make one quick change to it because there's something you didn't know, and I'll explain here. So what we're gonna do is we're gonna show that Charlie's code work and make sure this works right here, right top, and you'll get the following. I can show that again here in a second. So Charlie said, where's the relaunch button? It's the red, you'll see it up here on the red right there. So there it is right there. It's on the red arrow at the very top, the relaunch button. So the relaunch button will be on the red arrow at the very, very top. So one thing you didn't know, Charlie, which is all right, is height has a capital H, weight has a capital, and this right here, this will do it right here. So Charlie, your model works. And then what's really cool is this is the hardest code you have to write, because then you can visualize your model, make a visualization of it. You can get a summary of your model, and everything is just stored as model M. So if you notice right here, Charlie, I can do all of this and get all of these different plots related to my model. I can even get all the residuals of my model, just like this. There's every residual. I can even make predictions with my model, and there's all the predictions from my model. So if you notice, this object M right here is now your model. That's what you stored the model into, and that's what you get. Might have to send me a picture. Make sure the data is put in there. So could you do a scatter regression correlation? Yeah, exactly. That's what we get. That's what we get with here with the visualized model. So the visualized model gives you the scatter plot right here. And we should be able to get correlation. We could find if you want to do correlation, awesome. Thank you so much, Rocky Top. You can do correlation with it. I think if you just do this, I think if you go core, I don't usually do correlation this way. You might have to do, it doesn't like it like that. Another way, you know what we should do? What is it called in the, can you remember in the psych data set what it's called? If you want, Charlie, you can also do this. Associate, and look at this. Here's the correlations right here. So the Pearson correlation is this, and this gives you a scatter plot. And you see how everything is still just y tilde x comma data equals, and all I did was change this to associate. So now it tells me the association, it gives me the Spearman correlation. So all I did was change from using the LM function, because this is the name of the function we're using, to the associate function. So here's the p-value right here. So that's the correlation, and here's the p-value. So would we reject or fail to reject the null with this p-value? And think about what we're trying to investigate. We're asking, is there some sort of relationship between height and weight? Or do height and weight have an association? Like, is height explained by weight? In some way. And so here's the p-value. Exactly, the p-value is 0. So with a p-value of 0, what would you do? You're exactly right, the p-value is 0. You'd reject then, and what does that mean for what we believe about height and weight? Like, height and weight now have a what? It just means what we saw here is super unlikely by random chance. So it's also an estimated p-value. It's basically so close to 0 that it's estimated to be 0. It's not exactly 0. This is an estimated p-value via the simulation process or the permutation simulations, which that's a longer story than I want. We basically do simulations to simulate the p-value, and we simulate it by random chance. What did I say? Random. So we create simulated random chance results. And we observe that none of our random chance simulations make a discrepancy as large or larger than ours. So that's why we estimate the p-value to be 0. We could say that we have evidence that there's a strong correlation. Exactly, Charlie, you're exactly right. We have evidence of a strong correlation right here because what we observed is very unlikely by random chance. What correlations would be more likely by random chance? Correlations closer to what would be more likely by random chance? Because these are all correlations by random chance. And then here's our result. Our result was 0.6. And then these are the correlations by random chance. Exactly. Correlations close to 0. It's telling me that the expected house is less than 5 for some of these. Are you doing the political party one? Because the political party one should be fine. There's other ones though that have expected cell counts less than though. I think it's the family order one has cell counts less than that. So if it's the family order one, let me know, because that one will have expected cell counts less than. So here is the model they're making. So their model, yeah, it shouldn't. I might go take a look at that. Right when I finish this question, I'll take a look at that. Take a look at this, Charlie. This is going to get crazy. So with this model here, we have 2 x variables. R is completely free. R is completely free. R is 100% free. And it can do everything we're doing right now. Like all you do, that associate function I just showed you. If you were to go here and do handedness, because I already know some of the names of variables in here. If you had the data loaded in, click the wrong one. Here you go, look at this. There you go. There's the mosaic plot. And here is the chi-squared value. There's the discrepancy, and there's the p-value. And the degrees of freedom, this is a 2 by 3, so there should be 2 degrees of freedom. It doesn't tell you degrees of freedom. Yeah, it's so quick. And then this is just y tilde x. We're predicting handedness from this. So exactly, it just does it instantaneous. It's so cool because you just go like that, and then boom, you got your test result. Y tilde x comma data equals. So I don't know, it's really easy to practice. And let me send you the links real quick on how to download it. I will send you. And getting coding skills can really help. really good practice. Where is my getting started with our playlist? Here we go.
Disney Plus.
So here is the getting started with our playlist. I've got to go to another class, but you're welcome, Ryan. And I'm going to finish this one off right here because we're going to take a look at this visualized model and check out this, Charlie. We now have 2 lines. So we now have, we'll have office hours tomorrow. I'm changing around the office hours a little bit because I have a meeting. I have a Stats 1 meeting, but we will have office hours tomorrow. We will definitely have office hours tomorrow. I guess I might do them early, but there will be videos. And then Ryan, if you have a question you want me to do, you can send it to me and I can make sure to do it immediately. So if you want to predict weight from height, it would be, and then the tilde. Make sure to do the tilde because the format is y tilde x. So it would be weight tilde height comma data equals. Yep, that's it. You just switch the order of the variables and now you're predicting weight from height. That's 100% at Charlie. Excellent work because, yep, exactly. So that's called the formula format here. So this is your y variable and this is your x1 and this is your x2 and this is just the name of your data. So does that make sense right here? We're doing this y variable and then we have x1 and x2 and we're just giving the names of variable. Yep, I will send out an announcement, be like, office hours are at this time. Woohoo! You got it, Ryan. And so we have this model right here. If you notice, we have 2 lines. So we have a line on whether or not somebody's a homeowner and a line on whether or not somebody is not a homeowner. How to put in the data 19 quiz for the homework. Here, I'll look at that next. I'll finish this one off and then I'll talk about how to do that one and jump right here. And let me see how quickly I can do it. Because if I can do it, then there's hope. I know a few ways to do it, but I want to try to do it a quick way. So with this right here, is the strength of the relationship between last amount and recent average amount stronger for homeowners or non-homeowners? So when you look at this plot right here, Charlie, which of these has a steeper line? The no line or the yes line? Which of these lines is steeper? And I think Timothy's already right there because it's further away from 0, correct? Steeper is a good way to do it. You can just look to see which one is steeper right here. The line has a stronger slope. Does that make sense, Timothy? The line has a stronger slope. Since the black line has a stronger slope, the relationship is stronger. Does that make sense? So the steeper line has a stronger relationship between right there. And is the difference in strength of relationship statistically significant? So what should we look at as soon as we hear statistically significant? We should investigate to see if there's a what? Is the differences in strength statistically significant? We should investigate to see what? The p-value. And which, Charlie, amazing work. What should we look at for the p-value here? What should we look at for the p-value? What should we look at? P-value less than 0.5, exactly, Timothy. Amazing work. Working together, 201, 320, working together. Well, this one is the change in strength. So if we're looking at a change in strength, what should we be looking at? Is that Connor? I think it's Connor right here. What's up, Connor? I think it's Connor. So I haven't talked to Connor in a while. It makes me sad. Not much. I just made you mod. Were you not a mod on the channel? Are you on a different account? I miss seeing you, Connor. I just miss being on campus. I'll make it happen again. And then Timothy, Connor and Timothy. We got the p-value of the interaction right here, and it is super strong. So the p-value of the interaction is super strong right here, or very, very, very statistically significant. So although this might only look to have a small difference between the lines' slopes, the difference between the line slopes is statistically significant. So that's awesome right there. Great work. We can see the p-value. I'd quote the p-value. Difference in strengths. So where someone lives, setting, either rural, urban, or suburban, might make a difference in the amount they donate. Isn't the homeowner... Great job right there. You're right. Homeowner is significant, and so is recent average amount. So is the intercept, and so is the model itself. The inflated VIF from interactions is crucial. Yeah, and then we might see that. Yeah, we are seeing some more uncertainty due to variance inflation right here. Multicollinearity is playing a factor right there, Connor. Amazing work. And so we are seeing probably less significance due to the multicollinearity of the model. And that usually happens when you put in interactions because the interactions are built from the variables themselves. So they share the variation with the other variables. So Connor makes an amazing point right there. Variance inflation is playing a role in this. Examine the plot for visualized model when we predict last amount and from these two right here. and their interaction. So let's go grab this right here. And let's fit this model. We just need to swap out this right here. And I think we're good to go. Let's visualize the model. And there we go. What's the first question? If we compare households whose recent average amount donation is 50, which level of setting, and we are doing their interaction, right? And their interaction, good. So if we compare people at 50, which level of setting has the highest last amount? Great job right there, Timothy. Excellent work. So if we compare, Connor knows. Great job, Connor. Equation for variance inflation right there. If we compare at 50, which has the highest amount? I can't even speak these days. If we compare at 50, we were going to cut my hair this weekend. We ran out of time. There's never enough time. It's just getting absolutely insane. What's up, Colin? Good to see you here. Oh, thank you, Colin. You're awesome. And Charlie is just doing an amazing job right here. Charlie, you are right, because we can investigate it visually. And don't cut the flow, Connor said. And so Charlie, look at this. I mean, this is one of the last assignment. This is the last assignment for 320. For BAS 320, this is one of the last assignments. And usually, so Timothy and Connor and Colin, Charlie, take whatever classes you want, but usually people who take 320 are so afraid at the start with the coding. And Connor had Python experience, if I remember correctly. Connor, I still remember you day one of 320 sitting in the back row. And I was like, who here's coded before? And you're like, you raised your hand. You're like, Python. And I'm pretty sure. Tell me if I'm wrong on that. Because I remember that day one of 320. I got that vivid memory of like, who here's coded before? And you're like, Python. And I was like, that's awesome. And C++, that's what you said. Yeah, you were like, I've coded before. And Python. I do remember that you were like, I've coded before. And I was like, I was like, oh, that's going to be a good student. I shouldn't think that. If someone comes in with coding experience, it's a good sign. Like if you're like, I've coded before, I'm like, okay, good. Whew. You're going to be helping people probably. And you have been a huge help. Like, oh my gosh. Connor, we need to talk. I need to know how you're doing. I need to like some updates on your life. I know like we talked more last semester, I feel like, or before the summer. The world's even more on fire right now. So, so much. You should check out my custom changing seasonal decomposition forecasting. Yes, Connor, have you not sent me that yet? You know, I'm going to teach time series maybe starting this summer. I do need help with one problem with this one is done. Oh, sure. Which one do you want? Wait, 1,200. Did you write 1,200 lines or send me this? Send me this. That's because Connor's the man. Connor's putting me to shame. I've written like a couple hundred lines before. Connor's got 1,200 lines. You know what you do? Here's how you write 1,200 lines. This is how I'd write 1,200 lines. And then there you go right here. You just go like that. And then you go, or you could probably just do this. We're just going to write 1,200 lines. I'm writing 1,200 lines, Connor. I should stop. It runs. I just wrote a couple hundred lines of code. Oh, man. Oh, Connor, you got to send that to me. No. Which one are you working on, Colin? Which one are you working on? Oh my God, Connor, I gotta see this. I'm gonna be teaching. Time series, and let me show one last thing right here, real quick. What I'm planning on doing. This is something huge I have planned for the summer. Is I'm actually working on basically new stuff for. Here, I'll show you everyone what this looks like, and we'll take So this is what I'm working on for 201 right now. So if anyone, Charlie, tell me what you think of this. I'm going to add videos into this. The timescale method. I can use our relationship between probability of donating and the donor's age. You got it. We'll do that here next. So if you look at this right here, this is what the textbook will, like, this is what everything will look like. I'm going to add in videos. There's knowledge checks when you're done with it. So this is what you'll be doing for slides instead. Like, all data needs context. You can see like our basic 201 questions, but I don't know what people think about this. You can tell me like, oh, this looks better or worse, but you can actually go through and like read, like the point is you're supposed to read it, and then it gives you examples. And then it's supposed to, I want it to be that you actually have to go through and read these, like the Kroger Plus examples. but I don't know what people think of this. Like, I've been working on it. I need feedback. I'm going to put videos in it. I just haven't made videos for it yet. So there will be like video portions, but you go through and do like what are data. Yeah. And then so it shows you your completion on each part. And then I've got the knowledge check for like this one down here. You can check your knowledge and everything. And, like what is this type of variable right here? And then it actually links to Canvas. So you'll get your grades and stuff by doing this right here. But, oh yeah, well, I already, yeah, I've already gotten paid for this one. So I need to complete it. It's been such a busy semester. But here's the really cool thing. Last thing I'd say, and we'll hop to Colin's question. It actually can be done on like an iPad or anything. So you could be doing it on any sort of device, and it's going to look like, this is why I chose this platform right here. Is it's going to look, what's up, Nicholas? Good to see you here. Excellent seeing you. You can even do it on your phone. So whatever device you're on, it's meant to augment to that device, and you could be like reviewing statistics on your phone, and it's going to, it's a very malleable thing for the platform. Where's Brawler, Tiny Brian? Oh, they're all here. We're gonna do Colin's question here. We got Tiny Brian, we got Brawl, we got even Big Mega Brawl. Everyone's here. Tiny Brian, everyone's here. Everybody's here. The whole gang's here. Everyone's here. Me and the boys hanging out doing statistics. That's what we got going on. But I'm really excited about this platform right here, and continuing to make this. So I need to complete this and make it look super cool. That's my goal. Make this look really nice and get every chapter. And so the one thing I was going to say is once I complete 201, and we're going to do Colin's question right here. Once I complete 201, I'm going to go and try to do other classes. I'm going to do other classes and make them look really cool too. Here we go. Here we go. We found Colin's question. So I'm going to try to make all the classes look really nice like that. If you had time, would you help with 16 on the 320 review quiz? It's weird to me. Yeah. So yeah, let me take a look at that. We'll do this one. We got Colin's question right here. We're going to predict, what are we predicting? Between donating and someone's age. Now, I need to know from the chat, donating is going to be a what type of variable? Donating is a what type of variable? Donating is a what type of variable? We have office hours to finish up. Yep. And feel free to ask any questions, Rocky Top. Throw in those questions here. Data to R from Pearson. Oh yeah, we gotta do that next. GLM, donate. Is it donate? Is it age? I think it's got it. Let's see if we spelled the variables correctly. If you want to know if you spelled the variables correctly, and this is EX5 donor, I think. Yep. And then, data. And family equals binomial. Did I spell everything correctly? There's one way to find out. We did. All the rest of mine are with jump to find chi-squared and p. And then we'll definitely, sorry, I'm all congested today. We'll definitely do those tomorrow. Hop in, ask those questions tomorrow. We can do those questions tomorrow. And let's visualize this. Now this is going to look different. Why 320 does this look different right here? This doesn't look like a line. Now I know it might look like a line, but it's not really a line. This right here is not a line. What's going on with this? What's the deal with this model right here? What is this? It says something up here. It says that. What is the deal with this model? What is the deal with it? Oh, I just answer questions on Discord. Feel free to message me. So, and then you're calling, you're right. It never reaches 50%, so it's going to predict nobody donates. It's going to predict no one donates. And is this a line, yes or no? Is this a line, yes or no? And the answer's up here for is it a line? Is this a line, yes or no? Is it a line or you? It's not a line. It's a sigmoidal curve. It's actually an S shape. So the sigmoidal curve, the deal with why it looks like a line for the moment right here is because we're zoomed into it probably somewhere like right here. So it might look kind of like a line, but it's actually an S-shaped curve. It's sus. I like that right there. It's totally sus. It's an S-shaped curve, and we're just seeing this portion right here. That's what we're seeing for the curve. So we have this S-shaped curve is what we're seeing. And we're just seeing really close in on it. So I don't want to, like, I'm not going to, but I think you can kind of see the answer right now, Colin, that if we were to make predictions for somebody at 0, so there's a huge hint right here, and then I'm going to hop to the other question. We have to make our model right here by going, you know what, let's do this. Let's go predict using model M. I wonder if we go and do this. We'll do it the right way. New data equals data frame, and then age equals 0. And I think that'll work. Good. New data equals D, type equals prob, type equals response. I always forget. That does look to be correct. And if I remove that, it should drastically change what we get. Good. That's, yeah, it should be negative. So with this right here, what am I doing? I'm actually solving out and making predictions for this model. And I want us to go up to 100. And what do you notice about these predictions right here, Colin? What do you notice? Oh, no worries, Colin. This should help you out. But try to notice what you notice about these predictions right here. I'm going to keep doing this quiz because there's still a bit I do not think we touched on. It's just got 2 last questions at the end, I think. And let's hop over to talk about that. And then we'll talk about Charlie's question about how to get data into R. So let me go to the quiz and see if there's anything we didn't say. The fun of multiple people teaching a class. Review for final. Let me go look at the questions. And I'll definitely mention things tomorrow. You said question 13. What does question 13 start with? They don't have numbers on the side. What does question 13 start with? So if you tell me what question 13 starts with. The last few questions are weird. And then I'm wondering what, if it's entry, I might actually like take it and like, because I don't know if you have to actually write in the answer for it, because you have to write in the answer for this one, which one of the most computational heavy. How does that question look? Let me see it. I'm gonna need to change some grammar on it. Let me preview the quiz right here. Okay, let me go down. Okay, it's got the multiple choice. Yeah. That should be fine. Oh, they do have numbers when I look at it this way. I don't know why they wouldn't look at numbers. Okay, here we go. So are you talking about this one right here, Timothy? The categorical variable season has 4 levels: fall, spring, summer, and winter. It is represented by 3 indicator variables: season spring, season summer. Oh, yep, we'll do this one real quick. When season is fall, what are the values of these indicators? So, oh no, we'll do 60 next. What would the values of these indicators be for season fall? This one should be pretty easy. Like, I really love this one as a test question. This one, if you know it, it's like, boom, done. So when it's season fall, what are the values of these indicators? Boom. Yeah, you got that. That one's like, got it, done. The following 3 questions about logistic. We fit the logistic model to predict if someone is a smoker or not based on their gender and the percent they tip. Smoker is a categorical variable with no and yes. Gender is a categorical variable with male and female. We use the R code as follows, and we have tip percentage, and we have, there we go, good stuff. And then we have right here, Alice is a female who tips 15%. Bob is a male who tips this. Catherine is a female who tips this. This is a tough question. Okay. So it wants us to know, this is a tough question. So when we look at this right here, let's make an order for this. Let's go get the values of individuals right here, and let's figure out who's going to have the highest probability of, because we're trying to predict if someone's a smoker. So are we predicting smoker yes or smoker no? Are we predicting smoker yes or smoker no? What are we predicting? Smoker yes or smoker no? What are we predicting? Smoker yes or smoker no? What are we predicting? Smoker yes or smoker no? What are we predicting? Smoker yes or smoker no? Which one of those are we predicting? Smoker yes or smoker no? Which one of those would we be predicting? Smoker yes or smoker no? Any ideas? Would we predict? Oh, no worries. Remember, in logistic, the level of interest comes last. Don't worry, Timothy, you're doing an excellent job. In logistic, the level of interest is last. Does that make sense? So we're predicting smoker yes because that's the last level. So we're predicting smoker yes. And so if somebody is male, that's going to increase. Now, okay, good. It does say Bob is male. So right here, this is going to increase the probability. This is going to decrease, and this is going to decrease. Not that, I guess those are kind of neutral, but females have lower probabilities than males. And the big difference right here is going to be tip percentage, though. Catherine has a 5-unit difference in tip than Bob. She has a 5-unit difference. So we could solve all these out mathematically right here. And if you solve them all out mathematically, we need to go here and we need to solve, probably the best way to do it is to solve Alice. Alice is going to be 15% tip. So here's Alice's coefficient from tip, and then I'm going to subtract the intercept, and there's Allison's value, -51. And, did I just do I did 15%, good. And we could actually figure out let's just do it the long way. So we could take 20 times this right here. Got to make sure we're not making error on the mathematics. And then we subtract from this the intercept. And there's that, negative. I might need the extra digit. Probably fine. And then I think Bob's going to be in the middle. And so Bob is going to be 15 times this right here. And then we need to add to it the coefficient of male because Bob is male. And we subtract off the intercept. And there's Bob's value. Negative. And these are the logit of their function. These are the logit of their function. This is not actually their probability. To find the probability, we need to do e raised to over 1 plus e raised to. So it should be like e raised to the negative 0.51 over 1 plus e raised to the negative 0.51, whatever the value is. You just take this value right here and you put it through the following function, and this will get the probability out of it. So this will get the prob right here. This will get the probability that somebody is a smoker. Now, what we should know is that the higher this value, the higher the probability, and all these people are going to be predicted to not be smokers. They would just need to have a value over 0 to be predicted the level of interest. So since they're negative values, all of them are going to be predicted to be not the level of interest. We can show this. Let's just mathematically do one of these by going here and going to exp, which is e raised to, and then we need to put in the negative, and then over 1 plus e raised to, and then we get it up. What'd I do? That should be good. And, I lost the divide. There we go. And you notice the probability is less than 50% because the numbers here are negative. If the numbers had been 0, it'd be exactly 50%. If the numbers are positive, so we can put in positive numbers here, then the probability is greater than 50%. So just a quick evaluation of this can tell us very quickly that all these people are going to be predicted to not be smokers, less than 50% probability. But the lowest probability is going to be Alice, followed by Bob, followed by Catherine. And that should be good help for that question right here. I think the only things we haven't talked about are just these last two, right? So these last two, and I think I mentioned it in one class, but I'll definitely hint, AIC is a measure of how close the model is to the truth, and the most time-consuming method is going to be doing all possible models. Forward progression is just looking in a forward step pattern, looking at each model sequentially as they get closer, a lower and lower AIC, but the all possible is the longest method. So that should be, and we did mention, I know we mentioned closeness to the truth. All possible model means you literally make all combinations of the variables, which is very, very time consuming, which is why we rarely do it for larger data sets. You're welcome, Timothy. Excellent work. I really appreciate people working on that. Let's look at, it was Charlie's question, how to get the data into R quickly. So let me look up something real quick. Let's try this. Enter a table into R quickly. 12 two-way tables. Entering data with R. There's got to be a quick way. We could load it in. We could load a file, but I want to go like and just type it in. Let's see. Enter contingency table in R. So we could load the data. We'd have to save it and load it. This is data camp. How to create contingency. I know how to create contingency tables. Would not nearly be. How to enter data directly to make a data frame representing. Oh, this is it. This is it. Someone's got something here. It's a lot of work. Yeah, it's way more work than's needed. It's way quicker to load. So they're showing how to do it right here, which is what I've done before by making all the categories. Does Tidyverse have a thing on it? But the quickest way, and so I'll check over here in the chat real quick. Yeah, it would be easy. And so what you can do is if you have a file, yeah, exactly. And hey, Charlie, that's amazing. Like just finding a way to do it in Excel and stuff like that. Keep up the great work, because that's what we're trying to do. Is we're trying to teach people multiple ways to solve problems, and you are on the complete right track. If you save it as a CSV, which Excel can save as, is it electricity? Electricity. Say spell. So electricity. I don't know how to spell electricity. Oh, there we go. So if you have something right here, you can save as a CSV, and then you could load it in. And if you have the file already loaded on your computer, so you can load files in like this. So you can, if you have it loaded in Excel, you can get it loaded here. And all this practice is just making you better. But Charlie, keep up the great work. So this is just a read.csv file, and there's also read.excel. Like you can read in Excel files. So you just load up the package that reads Excel files, and then you could read an Excel file. Can't think of any Excel files, but now you go to read.xls, or you go to read.xlsx, and you just put the name of the file, and then you can store the object as something. So if you have the data already stored on your computer, you just put the path to the name of the file, and then you create the object it's going to be stored as, and you can store it in on here, and you can have the data loaded in. So it's easier. It'd be hard to recreate the data. It would take too much time, or it's just way quicker to save the data on your computer. But all this stuff right here, Charlie, the more you learn, the better you get with Excel, the better you get with Jump, the better you get with R. It's all great because it's all skill sets. And I think that's got it. Let's play some outro music right here. It's time to end class, time to end office hours. I'll be seeing everyone soon for 201. We have the Kahoot today. I'm going to go get a little more food. But that's got it for now. I'll see everyone later. Bye for now. Bye.